Hello viewers, in today's session we are going to discuss another important problem from the concept of beta and gamma functions. And in this class we are going to discuss this integral where we have the limits from 0 to 1 and the integrand is 1 minus x raised to 1 by 4 raised to 7, right? So here we'll solve this integral with the help of the definition of beta function and then making use of some important results from beta and gamma functions, right? So let us first use the concept of integration by substitution method. So let us first call this integral as I, and here we'll convert this integral into the beta function, which is m comma n is equal to the integral 0 to 1, and we have t raised to m minus 1, 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So let us make this substitution, that is t is equal to x raised to 1 over 4, and from this expression we can write t raised to 4 is equal to x, right? Okay, now if we differentiate both sides with respect to t, then dx over dt is given by d by dt of t raised to 4, and the derivative of t raised to 4 with respect to t is 4t cube, and dx is now equal to 4t cube dt, right? Now here the limits of integration vary from x is equal to 0 to x is equal to 1. So when x is equal to 0, then the value of t is 0 raised to 1 by 4, that is simply 0. And when x is 1, then the value of t is 1 raised to 1 over 4, that is equal to 1, right? So now this integral I can be written in terms of t as 0 to 1, and we have 1 minus t because x raised to 1 over 4 is assumed to be equal to t, and we have here the power 7, and for dx we can write 4 t cube dt. Now we can take this 4 outside the integral being a constant, so we can now write 0 to 1, and then we have t cube and 1 minus t raised to 7 and dt. Now let us write this integral as t raised to 3. Here 3 can be written as 4 minus 1, because here we have m minus 1. So we can write 4 minus 1, that is equal to 3, and then we have 1 minus t raised to 7, and 7 can be written as 8 minus 1, and here we have dt. So now this integral is given by the beta function. So we have 4 times the beta function m comma n, and m is equal to 4 and n is equal to 8. So we have 4 comma 8. So now let us find out the value of beta 4 comma 8 by using this important result, that is beta m comma n is given by gamma m times gamma n divided by gamma m plus n, right? So here we can now write 4 times gamma 4, then we have gamma 8, and we have gamma of 4 plus 8. So we can now write 4 times gamma 4, gamma 8, and then we have gamma of 12, right? So now we have to find out the values of gamma 4, gamma 8, and gamma 12. So we'll make use of this result, that is gamma n plus 1 is given by n factorial, right? So gamma 4 can be written as gamma 3 plus 1, that is equal to 3 factorial. Gamma 8 is equal to gamma 7 plus 1, that is 7 factorial, and gamma 12 can be written as gamma 11 plus 1, that is 11 factorial. So now we can write this integral I as 4 times 3 factorial, then we have 7 factorial divided by 11 factorial. So now we can write 3 factorial is simply 3 times 2 times 1, that is 6. And here we have 7 factorial. Let us write 11 factorial as 11 times 10 times 9 times 8 times 7 factorial. So here 7 factorial and 7 factorial get cancelled, and here we can now cancel this 8 by 2. Then we have 2 times 3 is 6, then we have 3 times 3 is 9. So we have now a 1 over 11 times 10 times 3, and this is equal to 1 over 330, right? So the value of this integral I is equal to 1 divided by 330.